Hi, my name is Benjamin Ortiz, and I will be your instructor for Math 0482, Math for Business, Science, and Education majors. What we're really going to be talking about here in this course is intermediate algebra. We're going to begin in section 1.2 of the online textbook. Instructions on how to set that up is available under course modules. There will be a homework section associated with these lectures, and they will be listed as section 1.2 homework. So let's go ahead and begin. Lecture 1.2 is going to be about algebraic expressions and sets of numbers. Before we do anything else, we need to establish some definitions. Okay, so a variable. This is a letter used to represent any number. Okay, and commonly in algebra we use x, y, and z. We are not restricted to those three. They could be any letter, and you'll see that throughout the course. Okay, so the next is a constant. So here we're talking about a fixed number. So, and generally by a fixed number, it's a number that we know. 1, 2, 3, so on. Okay. Or it could be a letter or symbol used to represent a fixed number. Okay, so for example, pi, we don't see any of the decimal values when we write it this way, but we know it's a constant. You could also see A, B, or C in definitions. Whenever we have these in definitions, though, we will establish what they are. You'll know specifically that it meant to be a fixed number or it's meant to be a variable. Okay. So, for example, we'll see a definition that says ax plus b. And we'll say a and b are constants. So that means x is the variable. Okay. So, but we'll always establish what we're looking at if we're looking at a bunch of numbers and symbols and letters. Okay. So, an algebraic expression. This is numbers and variables connected by operations. Okay. So, and by operations we mean the normal ones that we're used to: addition, subtraction, multiplication. And for multiplication, I'm going to list 3. Just so we can see the symbols here. So we very rarely use x to denote multiplication, like you may have seen in lower levels of math. Generally, you will see me use an asterisk. You might see me use parentheses. Or then you may see me do something like this: a times b, where a and b are just numbers. Okay, this specifically is called juxtaposition. And really what it means is that we're not writing an operation, we're just writing two numbers next to each other, and we're implying that multiplication needs to be performed here. Okay, and then finally we have division. And here we will use the division symbol a little bit, but it's not very common after you start higher levels of math. Most of the time we will be using fraction notation to denote division. Okay. Some other couple of things that I would like to add on here that may not be explicitly defined as operations with symbology, but there's still forms of this. So let's identify some of these things now. So exponents will have a and b. And then the eighth root of b. Okay, so radicals. And the reason I want to list these out specifically with the a and b, then the exponents, and then the radical is because you're allowed to use a calculator in this class. And I would really like for you to take a moment and look at your calculator and find these buttons on there so you can start familiarizing yourself how to use your calculator now. Available in Canvas under modules, there is a picture and a description of the calculators that are allowed in this class. I would very much prefer that you use these calculators in class. A phone calculator, while it's easy to use, really isn't acceptable for your academic career. And if you're starting off in my 482 intermediate algebra class, you'll need to be familiar with a scientific calculator when you get into your next course, whether it's college algebra, maybe it's business math. Some people might decide to take statistics, but your phone is not really an acceptable substitute academically. So get one of those calculators. They're not very expensive, and familiarize yourself. Okay. So let's look at some examples of algebraic expressions. Okay, so 3x plus the square root of 2. Okay, here x would be a variable. This isn't really something that you could stick into your calculator right now and solve, but it is a algebraic expression. There are two operations happening here, actually three. We're trying to take the square root of 2. We are using addition, and right here we have 3 being multiplied to some variable. Okay. We could have x squared plus 4x plus 4. We're going to do some work with stuff like this, learning how to factor it and do different things with them, but it's an algebraic expression. Here we have an exponent happening, so we have repeated multiplication. Here we have juxtaposition, so 4 and x are being multiplied together, and then we're using addition. Okay. We could also have 3x divided by 4y. Okay, so juxtaposition has 3 times x in the numerator and 4 times y in the denominator, and then division is happening between them. Then the square root of x squared, so we have repeated multiplication and then taking the root of that. So those are just some examples, just so we can see the kinds of things that we're going to be looking at this semester. So what about evaluating algebraic expressions? Okay, so the key word here is evaluate. So throughout this semester I will highlight a lot of words to look for the homework or during an exam. So when we're asked to evaluate something algebraically, we plug in a number for our variable and simplify. And by simplify, it means we're going to perform all the operations we can perform after we plug in that number. Okay, so example 1. So let's say I had a rectangle. Okay, and it has some length L and some width W. And if I wanted to find the area of this rectangle, I would have L times W. Okay, so this is an algebraic expression all by itself where L is equal to length, W is equal to width. And this is telling me, since I don't see an operation happening, that I need to multiply these two numbers. Okay, so we can find the area if L equals 5 feet and W equals 3 feet. Okay, so area here equals 5 feet times 3 feet. Okay, so I plugged in 5 feet for L and I plugged in 3 feet for W. Next, I need to simplify. I can multiply 5 and 3 here. Okay, I don't have a plus or minus sign in between the two parentheses, so that tells me everything needs to be multiplied together. So here I've got 15, and when we work with units, we have to perform operations on those units as well. So we need to think I've got feet times feet, and that would give me feet squared. It's repeated multiplication of the same thing. Okay, so if I had x times x, I could rewrite it as x squared. If I had 2 times 2, I could rewrite it as 2 squared. And so here I have feet times feet. We're going to treat that unit as if it was a number, and we're going to multiply it together. Okay, so don't forget about your units, and we'll see lots of examples through this in our words problems. Okay, so what if we are asked to evaluate b minus 5a for a equals 3 and b equals 10? Okay, so they're giving me numbers to plug in to evaluate, and if you're being asked to evaluate, there's always going to be numbers for you to plug in. You just have to identify where it is that they go. Okay, so here my expression is b minus 5a. I need to take 10 and plug it in for b. And notice there's nothing really happening to b. There's not a constant in front of it. There's no multiplication. There's no division. There's not a negative sign in front of it. There is one behind, but I'm okay to just rewrite b as 10. Okay, minus, I still have my 5 here, and then I have 3. And remember, if I'm using constants, juxtaposition probably isn't the best way to write this. So we could write 5 times 3. Okay. So now I've plugged in my number, both of my numbers, into my algebraic expression. Now I need to simplify. And I know we haven't covered PEMDAS yet, and we will soon. The first thing that happens here is multiplication. So I've got 10 minus 15. And now I can perform the subtraction, and that gives me negative 5. So sets of numbers. Let's talk about some sets of numbers. In math, we like to classify things, and we like to classify things that have the same types of properties, so we can talk about them very much in general. Okay, so sets of numbers. First, we're going to talk about the natural numbers. Okay, you may also know them as the counting numbers. So here, I've said that the natural numbers is equal. These squiggly lines right here, we use them like parentheses. They are called braces though. And my set of my natural numbers begins with the number 1. I use comma to separate my elements in my list, so each of these numbers would be called an element of that set. And the set is natural numbers. Okay. And then after 3, I know this pattern that keeps happening. You know, the next number up would be 4, then 5, then 6, and so on. And so that's kind of what these little numbers are telling me. That's just going to continue on. Okay? There is another way to write the natural numbers as an extreme shorthand, like if you're talking about them but not actually using them. So that would be a double struck N. And you may see me write this through the semester. I'll try not to do it a whole lot, but it's just a good thing to know as you progress through your math courses. Okay, so this is a double struck N. So we can call this a general symbol. Okay. This right here, the way it's written with the braces, the commas in between each elements, the ellipses, which mean this pattern continues on without end, this is called set notation. Okay, set notation. We're going to use set notation a lot. There's different ways of writing sets, and we'll see a bunch of them. Okay. These 3 dots are ellipses, and this means the pattern continues. Okay, because it happens at the end of our set notation, that means it continues that way forever. Okay. So this was our first set. Just so we can have some kind of separation there. The second set of numbers that we're going to talk about is the whole numbers. Okay. So for whole numbers, we start with 0, and then we continue on with the rest of the natural numbers. So the only thing that's different is 0. Okay, so we've added this in. As far as some kind of symbol like this, we don't really have one for the whole numbers. There's some very formal ways of doing it, but that's not necessary for you to know. So the third set of numbers that we're going to talk about are the integers. So oddly enough, the integers have a general symbol, and it is a double struck Z. So the integers. We'll use this a lot. Now, here for the integers, I'm going to have ellipses at the very beginning. The integers introduces the negative whole numbers into our number sets. Okay, so -3, -2, -1, 0, 1, 2, 3, and so on. Okay, so this continues off towards infinity on the positive side, and this continues on to negative infinity on the negative side. And so where ellipses are in set notations tells you something. This also continues without end going this way, to the right, to the left, excuse me. And this side continues infinitely to the right. Okay? So let's write that down. That continues in both directions. Now the next set of numbers, 4, we want to talk about the rational numbers. The general symbol for the rational numbers is a double struck Q. The rational numbers. Now, for the first 3 sets that we've talked about, set notation is fine to just list out the beginning elements of our set. Here, this was enough to write out a portion of the pattern, and then we could see that it went on in both directions. Okay. For the rational numbers, though, that is a very complicated thing to attempt to begin doing, so we don't. And what we do instead is write a short description of the rational numbers. So the rational numbers are what you would think of as fractions, 2/3, 1/2, and that type of thing. So we still use braces for set notation, but now I'm going to write A over B. Okay. Then I'm going to draw a vertical line. So this is the form of the number that I'm talking about. And then I'm going to say A and B are elements of the integers, comma, B is not equal to 0. Okay. So reading this, we say a rational number has the form A over B such that is this vertical line right here. Excuse me, sorry about the camera. Such that is the vertical line. So numbers A over B such that A and B are elements of the integers and B is not equal to 0. Okay, so the rational numbers are numbers of the form A over B, where A and B are integers and B is not equal to 0. Okay, so remember, it's often easier to write a short description of our set. So this symbol right here, I'm going to put a little star. Okay, that's like a little E, and it just means element of. We have another set that we're going to talk about this semester, and that is the set of irrational numbers. Okay, so rational numbers are all the numbers that we can write in rational form, in fraction form. Irrational numbers is the set of all numbers that cannot be expressed as a quotient of integers. So it means I can't write it as a fraction using integers in both the numerator and denominator. Okay, so let's write that down. Okay, the set of all numbers that cannot be expressed as a quotient. Remember, quotient means division of integers. Okay, so you have a formal definition that you can refer to. How would we write that in set theory? Well, one way would be all numbers x such that x is a real number. Okay, and I know we haven't talked about this symbol or the real numbers as a formal definition yet, but we'll do that next. And x is not an element of the rational numbers. Okay, so on the last page we had this meant element of. If I strike it, this means not an element. Okay, but basically it means this is a number that I cannot write as a fraction. Okay, so the square root of 2 pi. We have a number called Euler's number, or short for E, the natural number. Okay. So the real numbers our general symbol for the real numbers is a double struck R, and I will use this a lot. It's in one of your Canvas check your understanding quizzes over this section of your notes. So be aware, this stands for the real numbers. So the real numbers is the set of all of the numbers that we've just talked about, the natural numbers, the whole numbers, the integers, the rational numbers, and the irrational numbers. Okay, so it's everything. When I say a real number, it means everything that we've just talked about. Okay? So we could say the real numbers is the set of all rational and irrational numbers. Okay? So one of the things that I may not have explicitly said is that the natural numbers, the whole numbers, and the integers are all part of the rational numbers. Okay, so the integer -3, I can write it as a rational number knowing that I can write any number over 1. Okay, so -3 over 1, it is still a rational number. It's still a real number, and I haven't changed the integer. Okay, so the real numbers is easiest thought of as the set of all rational and irrational numbers. Okay. Okay. For future reference. Okay. So we call our number system that we're going to use most of the time the real numbers, and these are all the numbers that you're familiar with. There is another set of numbers coming. That's called the complex numbers, sometimes referred to as imaginary numbers. So those are numbers of the form a plus bi, such that a and b are real numbers and I equals the square root of -1, the imaginary unit. Okay, so we're not going to use the complex numbers very much at the beginning of the class. They will be addressed. I just wanted to talk about them now as we're talking about sets of numbers. Okay. So let's look at some examples real quick to kind of end off this video. Examples. I may ask you true or false questions, such as, is 0 an element of the real numbers? Well, we know that 0 got introduced in the whole numbers. That means it is part of the real numbers because the whole numbers are a part of the real numbers. So that would be true. Okay. Another good true or false question would be, every integer is a rational number. Okay. So you may see some questions of this style, true or false. It shouldn't, in your Canvas quiz over this section of the lecture notes, it shouldn't be too much trouble. Okay. I'm going to go ahead and end this portion of the lecture. We are not done with section 1.2. There is another video that follows where we will continue talking about sets of the real numbers and algebraic expressions.